Okay, so we have Unit 2, Lesson 8 video notes. And this is where you draw in your Cornell boxes because we're going to take some notes. Also your summary at the bottom. Oh, there's a hair. Okay, so the title of our notes is Solution Sets of Equations and our new word, Inequalities. So this is a new word, Inequalities, and I want you to think about anytime you've heard of this word. You might have heard of it when you talk about your Pac-Man mouths. This is less than, and this is greater than. And there's, in this part here, there's a component that is bigger. The space between these 2 points are bigger, and the space between these little points are smaller. So this is an inequality sign. Inequality sign. Okay, so you might have heard of these before. During this video, you are going to be able to explain how to represent an infinite solution set represented by inequality, and then you are going to be able to do to write an inequality solution set 3 ways: graphically with a line, words, and set notation. Okay, so here is example 1. Example 1. We have a single solution set. One solution. And we know that 7 plus p is equal to 12. We have seen this this equation before, but let's find the one solution that makes this true. So if we subtract 7 from both sides, we'll get p is equal to 5, which is good. So in words, 7 plus p equals 12 has a solution of 5. In set notation, this is review notation, the solution set is 5 with these curly brackets, and graph. If we graph the solution set, we draw in a line. Don't need a ruler, but you can use a ruler. If this is 0, and we have 1, 2, 3, 4, 5, then we have a single solution set, which is this dot, and it has to be colored in the entire way. This is the solution set written in words, notation, and on a graph. Okay, out of your big ideas, maybe you can write, there are 3 ways to write a solution set. And you will have to know all 3 ways to write the solution set. Okay, that was example 1. We've seen solution sets with equations before. Now, let's work on example 2. Remember, if you need to pause the video, you can pause the video to catch up. An infinite solution set. I really hope that you have been introduced to this word. Infinite is also a vocabulary word. The symbol, this just means like it's not a number because it's bigger than a million, bigger than a billion, bigger than a trillion. It's not a number. It's just the idea that there are very, very many, a very large number. In symbols, it's denoted by this lazy 8 right here, this infinite sign. Okay. We are going to find the solution set for the expression x 3 plus x that's equal to 3x plus x squared. Okay, so you don't actually know how to solve this yet, and that's okay. Let's use our properties. How did we go from this expression to this expression? Well, we use the distributive property, of multiplication over addition. Now, because we know our properties, we know that the distributive property of multiplication over addition does not change the solution set. What I'm also going to tell you is that this equation, because these two sides are equal, every single number I put in for x, it will equal this side. If I put in a 0, I put in a 0, they will be a true statement. If I put in a 1 and a 1, it'll be a true statement. A 2 and a 2, a negative 1, a negative 1, a negative 2, a negative 2. Either way, it will come out to be a true statement the whole time. What does that mean? The solution in words is all real numbers. There are a lot of real numbers in the world. There are an infinite amount of real numbers. And every single number, if you plug it in for x, for all the x's, it will be a true statement. Okay, set notation. Now this can be really hard because in set notation, I can't write like a bracket. I can't write a bracket and write all the numbers in the world, and that's my set notation. There's got to be an easier way to write all real numbers. Well, there is. You draw a capital R, but instead of one line, you draw two lines. And what that means is all real numbers. This capital R means all real numbers. Okay, on a graph, it's great. This is how you graph it. Graph. Draw a line. It is literally just if this is all the numbers, you literally just draw in a little darker all of the numbers. If you have these arrows on the side, then you're good to go. Okay, let's move on to our next example. Okay, I'm going to turn the page. You are going to fill in your summary so far. Maybe your summary is this means all real numbers. And maybe you write that solution sets are written three ways in our algebra class. All right, if you have to pause here, but I'm going to flip the page. Okay. Example 3. Unit 2, lesson 7. Oh, this is 7. 8. Notes. Continued. Okay, drawing our lines. All right, so I've got boxes everywhere. That's good, that's good. Okay, example 3. Let's find an inequality. Oh, here's our new word. Very exciting. Solution set. Let me give you an example. What is, let's see, solve x over x is equal to 1 for x over positive real numbers. Okay, so this means over positive real numbers means that any number that we plug into x has to be greater than 0 or positive. So this means greater than 0, greater than 0. Okay, let's start plugging in numbers. What if x is equal to 2? What if our solution set is equal to 2? 2 over 2 equals 1. This is true. Okay, that works. Let's try decimal. 0.01. So if we plug in 0.01, that still equals 1. That is still true. Okay, so I tried a really, really small number. I tried like a normal number. Let's try x is equal to 10 to the 100 power. How about that? Oh, that's got to mess things up, right? 10 over 10 to the 100 power over 10 to the 100 power. That's still equal to 1. Okay, all these are true. I know. How about this? Let's try an even smaller number than 0.01. Let's just, it's not a positive number. This is not a positive nor negative number, but let's just try this to see what happens. This is undefined. 0 over 0 is undefined. Therefore, it is not true. So, every single number we tried, even though they were weird, worked, made this true, except for 0. Granted, it wasn't a positive real number, just like the said, but now let's write this in words. And by this I mean solution set. Solution set in words. The solution is all positive numbers. I should put all positive real numbers. Okay. For set notation, it's really hard to write every single real number if we write it all over here. It's really, really hard. But what we can't write like 1, 2, 3, 4, 5, 6, 7, 8, 9, 100, 101. We can't just like write all that in there. So there are these shorter hand ways that we could do this. What we can do is we can write that the answer, the solution set in this curly bracket is x, all the real numbers of x. And then you draw a bar. This is not a 1, this is not an L, this is just a bar that goes the entire length of the letters. For x is greater than 0. Okay, so this means for, I'm going to write this is how you read this. The solution set is all real numbers such that, and that's what this bar means, such that x is greater than 0. Okay? X is greater than. So I'm going to put in a little note. X is greater than 0. This is greater than 0. And then over here is less than 0. As an example, x is less than 0. So the Pac-Man mouth or the alligator mouth points to the, well, you read this as less than. This is the less than sign, and this is the greater than sign. And the space between here, like this is really big, the space right here is really big, and the space right here is really small. So that's how you can remember it. Okay. Finally, let's do the graph interpretation of this graph. Okay, so to graph this, what we do is we have 0, 1, 2, 3, etc., etc. And this means that all the numbers have to be greater than 0. And it can't equal 0, because we tried to equal 0 and then it became undefined, our equation, our expression. So what we're going to do, I'll do it in a different color so you can see, is you are going to leave this circle open. Do not color this circle in, leave it open, and then color all of the lines that are greater than 0. Okay, so let's do this. Open notation, open circle, closed circle. For an open circle, it is going to be your less than or greater than sign. You're going to have open circles. Just like here, it was an greater than sign, so it's an open circle. But if it is a closed, you will have to close the circle, which means you color it in if it says less than or equal to, or greater than or equal to. Okay, so go ahead and take the time to fill out this summary and see what you get. This is something that you're going to write right now on your own, and then we are going to, and that should end the video. Okay, bye.